Welcome back to chapter 4. Let's continue where we left off. So the reason why it's going to have a lot of errors is because we have not imported all the dependencies, and so it's going to create a lot of issues. But we can just click on this, and basically we don't have any inputs because this is not a controllable character, and so we don't need all of this, and we don't need all this. Yep, we don't need that. Don't need that. So it should be empty. Let's try to compile it. So that's fine. Save. And also, let's go into viewport. And let's see here. Okay. So I don't think we need these either. So get rid of the functions. We also don't need a camera and this arm either. So just that. Going to compile and save. So this is as plain as it gets. And this is the state that we use AI characters or NPCs. So that's that. I don't want to change this, as I said. And so I'm going to drag and drop this into BP folder and copy. Let's rename this to BP Stickman 1. All right. And in order to specify this, I want to, where's that? In the mesh, yep. And in here, animation mode, use animation blueprint, and we select our own, which is over here. That's that. And let's just see the viewport. The skeletal mesh asset is this one. So it's extremely small. So we need to basically, what do? We need to bring this center. So the jumping animations is a little annoying, but let's just get to the front axis, which no idea how you're supposed to do. Oh, it's probably this one. Yeah, front. Okay, I'm going to zoom in and just change the size of the capsule. So height. Okay, maybe 20 or something, right? So it's way less. Maybe 10 here. Looks fine. Yep. And then the height maybe is 20. Maybe 22. And so it's kind of sitting there. So I'm going to just line this up down here. And I just want to move the capsule up. No. So what I'm trying to do is make sure that it's lined up, right? Because the collisions is important. Very annoying. So maybe minus 18. Okay, there you go. So it's minus 22, right? There you go. So if you want to follow that, minus 22, where's that? The capsule size is 22 and 10. So that should work now. And so let's compile and save. Currently it doesn't have any movement, so we need to actually set this up here next. Okay, so for the movement, we'll be using a few of these built-in functions provided by Epic to help us control AI characters. Of course, the workflow is different from controllable characters in terms of using user inputs, but this has to be controlled by the game. And so that function first is going to be called AI move to, this one here. And so I want to run this from event begin play. Let's connect this here. And then I need to give it a pawn that will control it. It's going to be the actual blueprint. So it's going to be this blueprint itself. So call it self and connect that here. And this, I want to give it a random point, but a specific function that is also provided by Epic. It's called a random reachable point in radius. All right, so do that, put it into here. And the origin will be from the actor's location. So get actor location to the origin. So the radius is going to be from the actor's location. Let's just do 250, right? And it'll be any random point in 250 that's also within the reachable point. So reachable point, of course, we'll get into the navigation bounds volume and stuff like that, which will come later. And next thing is the acceptance radius. Just point that this AI will accept. let's just make it 250. So for example, if we just like put in something like 300, if there's a point that's further than 250, it won't go. Hopefully you understood that. And so what I want to do is I want to use this onSuccess pin, which will fire after the character has reached this point. And I want to just keep looping it. So to do that, I just need to put in a delay here and loop this back around. Not the best thing to do, but this will be good enough for the test. And so once it arrives to the point, it will just delay for 0.2 seconds and then back around and walk to a new distance or a new point. And so this should be fine. So now we can compile and save. The next thing I want to work on is to set up a test environment where we can test this actual blueprint. And for that, we need to set up our level. And so for a level, let's put in a plane, zeroed out, and let's make it 10. That should be good. And I need a light, so let's drop in a directional light, make it 2 for intensity, zero that out as well. That looks fine. So for these AI characters, we need to give it more information so it knows where it can walk around. And so that's the volume that I was talking about. So to get that, you do more here, volumes. We can just find it here, the Navmesh Bounds Volume. So just drop that in here, zero it out. And so you can see now this green area is where the AI can walk around. And if you don't see this, you can just click on the viewport and press P to toggle. And so this area is way too small. And so I'm going to just increase this volume up by 600 in all axes. So that's probably looking good. And so what I want to do is not actually make this walkable area a square, but a circle. How do we do that? Well, basically, we just use a cylinder. So let's go to shapes and cylinder. Zero that out. And so this is obviously incorrect. And this plane, I just wanted to use as a visual thing. And so let's click on the plane and make sure it's ignoring the collision. So collision presets to no collision. So that goes away, no step on. And then let's click on the cylinder. And if you start to scale this up, you'll see that it should start providing us with a round walkable area. And I'm going to give it like 6. And I'm going to now go to a side view and drop this down. So it's flush with the ground. So let's see, that's going to be minus 300. And if we go back into the perspective view here, now you can see that's the area. And for the plane, I want to use a grid material to see something which you will check later. So let's call it a grid. And if you don't see this, select engine content here. And then you'll see a proc grid, this one here. And now you see there is a Z fighting going on. So I want to select the cylinder and make it invisible. So visible, uncheck that, because of course this is for only collisions. So that's basically set up now for the test. I'm going to press P to get rid of that and drop in a couple of our Stickman here. And maybe take one and rotate it around in a different direction. That's cool. Now we are lacking a camera, so just drag in a cinema camera, pilot that, and just give it a random position like here, you know? And of course, we need to actually specify this camera to look at or look through. I like to just do in the level blueprint, so open that and make sure you have the camera selected. Right click to create a reference to that. I need to get the player controller over here. And then there's a function called set view target with blend. And I run this from begin play. And let's just connect this here and here. So if you just open this initially, you'll see it already here. I tweaked it a little bit before, so it's not there. But anyways, this is ready to go. If you don't understand this, I've already explained this like a ton of times in prior courses. So yeah, you should get an explanation there. So compile and save that. So now we should be ready. Technically, we can test this, but you'll see in a moment that it's completely messed up. So press and play. All right, so it's not even walking around for some reason. All right, seems that I made a mistake. This acceptance radius should be like orders of a magnitude smaller than this value of the random point radius. It should be a tenth actually. So it should be like 25. I'm wondering if the scale of this is different from this one. I'm not actually sure. But anyways, this should basically work now. So compile and save and give it a run. You'll see that it's completely messed up, but it does kind of walk. Play that. And you'll see that there's an issue already as well, is that we're actually supposed to wait until the landing animation finishes and start walking. And you can see that it's walking way too fast because we haven't specified the values of our different walking speeds. So let's discuss that next. Before we start tweaking the values inside of the character movement component, how do you even know which values to tweak? Because there are very many of them. For basic AI characters that are just walking around at a constant pace, there are 3 categories. So this is the first category, second, and the third. So the first one is here, the max acceleration from idle to walking. And then the next one is the top speed of the walking. And there are actually several of these values. And at the end, it's the backward force, which is the braking force. So those are the ones that we're going to be tweaking. And then the next thing you want to pay attention to is the scale of these characters and the differing stride lengths, which is basically just a gap between the front and the back step. And for the little guy that we have, like the Stickman, it's going to be a way smaller value. I think on testing it was around like 35 to 50, but with the space guy, even bigger than the Stickman, has a much wider stride length. So it was around like 50 to 75, I believe, especially for these values here. And the acceleration is going to be a little bit higher because you should allow it to accelerate faster than the top speed. Yeah, and then the braking force can be a little higher. And so that's what you need to keep in mind. Let's go ahead and tweak these values. All right, now you should have a pretty good idea of which values you're going to have to tweak to get the desired movement. So if you remember, this original blueprint came from the third-person template. And that mannequin, that skeletal mesh, is way bigger than these little guys here. We need to dramatically decrease the values that is currently set inside of here, inside of the character movement component. So of course, remember acceleration and braking. You can see this one here. This is way too much. That's why it was like going like super fast. We need to decrease this to maybe like 45. Don't quite remember. And the actual walking speed, anything that has walk in the keyword. So I'm going to just change this to like 35, 35, 35. The actual values that is important, I think, is just going to be this here and here. The minimum and maximum walk speed, keep it consistent there. And the braking, the acceleration walking, this is the next one, should be maybe like 50, a little higher than max acceleration. So these should be fine. The next thing, right, I want to touch is the turning speed, which is down here, rotation rate. So this one, we're using the turn in place, and if it's really fast, it looks really ugly. So let's reduce it down to 300. That's more or less ready. We'll, of course, tweak these values much more later, but for now, we can compile and save this and run it once again. Actually, before we do that, let's just put in a delay here, because if you remember, the walking should begin after the landing. Don't really know how many seconds that is, but maybe we can give it like a second. Should be okay. Let's compile and save that. And let's run this. So boom, landing finishes. Looks all right, but the acceleration is still not so good because you can see it's still sliding. And the reason why you want to use a grid material is because you can see that sliding or the moonwalking much easier than if it was just a plain material. So just give it a observation. You can see that it's skating a little bit, right? So it's a little too fast, the walking speed. And the acceleration is also too fast, it seems. So again, for that, of course, you need to start playing around with this. Give it like 40, could be like 38 maybe. And then the actual walking speed was definitely too fast. Give it 30. Braking should be okay. Let's just compound save that. Maybe we can zoom in a little bit. And I feel like it's not flush with the ground. For that, just go into the viewport. Let's get a front view here. And we can probably just drop the mesh itself down by 1. So let's do like -23. And that might fix it, so save that. Okay, so it seems like it's contacting the ground much better. So as you can see, that's not good. And probably because we need to give it a bit more delay. We will deal with this later as we can receive an event from the animation blueprint once the landing animation has finished. But for now, it's a test. Play once again. All right, and looks a lot better now, but you can see it's a little bit of skating there. So, we can probably tweak that later. All right, so we are finally 1 hour into the course, but we still have more to go. And so onwards, we have to repeat the same steps. We did it for the Stickman, for the Spaceman. And if you're feeling discouraged, don't be, because this is normal, right? Because you're not doing linear timeline workflows. It's a lot like delaying your gratification, because when you're coding, a lot of things you can reuse later, and so they pay back at the end, and you don't have to put in the same half an hour or an hour to set it up. So if you want to keep learning, click on the next video.